Good evening everybody, and welcome to the video. In this promo video, I'll be talking about what I'm gonna be teaching you all in my course that I'm about to upload on YouTube for absolutely free. This course, the title would be Learn DynamoDB, Become an Expert in a Fun and an Easy Way from Zero to Hero with Labs. In this session, I'll be covering various aspects. I'll be essentially talking about myself first, and then I'll be covering about what is DynamoDB and why is it so trending. Supported data type, scaling option, partition key, GSI, LSI, scans, string. So basically eventual consistency and strong consistency. We're going to talk about DynamoDB streams. We have some amazing popular hands-on lab where I'll be teaching you from basic, again assuming you don't know anything, how to essentially create a DynamoDB table using Serverless Framework, how to deploy, how to query the table, every single thing step by step. I'll be walking you over that. Then also we'll be creating a data archiving architecture with DynamoDB streams. We'll be essentially building an architecture to power downstream system using DynamoDB, essentially using stream, publishing to an SNS. There are a couple of hands-on sessions, and in the end, we are going to also discuss some popular interview questions that you can expect in DynamoDB. So this course is essentially designed in a way that you don't know anything, and we'll cover right from zero basics all the way to hero with labs and tutorial with code snippets. So I hope you're going to join me on my YouTube channel to learn more about DynamoDB. Yeah, I'm really excited so you guys can join on my YouTube channel for this course. It's absolutely free, and do expect this content to be published by the end of this week. Thank you so much, and I hope you will appreciate all these amazing contents that are coming on my YouTube channel. All right, I'm really excited to teach you more about DynamoDB in a fun and a very easy way with all the amazing labs. So let's get started with the video. So first of all, I'll begin the course by introducing myself. So if you're watching me for the first time, hey everybody, I'm Saumil Shah. I hold a bachelor's in electronic engineering, and I have done my double master's in electrical and computer engineering. I have an extensive expertise in developing scalable, high performance software applications. I also have a YouTube channel where I teach people about machine learning, Elasticsearch, AWS heavily, right? I work as a data collection and processing team lead at JobTarget currently, where I spend most of my time developing frameworks, pipeline, microservices, data lake, warehouse, etc., etc., etc. I also have worked heavily on streaming application using Kinesis Streams, Kinesis Firehose, Kinesis Analytics, and much more. If you further like reading, I have published a couple of articles that you might be interested. For example, event processing of data streams, optimizing SQS processing using efficient end user querying, right? We have article published on semantic search, data lake, right? Automated data ingestion framework, right? So all these articles are there, so you can read if you guys are interested in that. And if you further like learning, I have a lot of section on my YouTube where I teach about Serverless Framework, step functions, Lambda, event-driven application, SNS, fan-out models, and there are so much of contents there, right? Data lake, Athena, CTAS, and so on. So what you are about to learn in this section or the course would be as follow. I think I have a small typo though. So we are going to learn about what is DynamoDB and why is it so trending. Supported data types in DynamoDB. We are going to read and explore about scaling options in DynamoDB. We are going to talk briefly about partition key. What are the best way in which we can select a partition key? Some data modeling exercise, global secondary index, local secondary index, scan query, strong consistency and eventual consistency, DynamoDB streams. We also have hands-on labs on creating a DynamoDB table with Serverless Framework. So we're going to write we're going to write the infrastructure code. We're going to populate the table. I'll show how to query the table. I'll show you how to set up a GSI, LSI. We're going to essentially create data archiving architecture from DynamoDB using Kinesis Stream. We're going to also learn to power downstream users through DynamoDB streams by publishing events to an SNS. I have a lot of hands-on session. I'll I'll essentially insert or edit this video and insert a video that I have already on my YouTube about developing global, developing active backend with the DynamoDB global tables. And then at the end, I will basically discover some popular interview questions. So I hope you are excited. So let's jump straight into the first section about introduction. So what is DynamoDB, right? Why is it so popular? Why most of the companies are trying to migrate their data into DynamoDB? What is the reason, right? There must be something in DynamoDB that is making it most popular in the industry, right? So let's read by a definition, what is DynamoDB? Because this is also a question could be asked in an interview. Hey, what is DynamoDB, right? You want to say Amazon DynamoDB is a fully managed, serverless, key value NoSQL database designed to run high performance application at any scale. DynamoDB offers built-in security, continuous backup, automated multi-region replication, in-memory caching, and data import and export tool. That is why DynamoDB is popular, right? All these features makes DynamoDB pretty attractive. And on the bottom section, you will find the reference if you want to read more about that. And all these materials or the slides are also there on the Google Drive. Please go ahead and read if needed. Well, they might ask you, hey, could you tell us some of the use cases of DynamoDB? So here are some of the use cases, right? Developing software application, build internet scale application supporting user content, metadata, and caches that requires high concurrency and connections for millions of users of requests per second, right? DynamoDB is known for its scale, right? It can scale for millions of users, right? Millions of requests as well, right? Create media metadata store, scale throughput and concurrency for media and entertainment workloads such as real-time video streaming, interactive content, and deliver lower latency with multi-region replication across AWS region. A lot of companies do store the metadata in the DynamoDB. For example, let's say you are a company working with videos, right? Maybe storing the metadata of a video, right? Or if you are a company that is dealing with large amount of images, right? Storing the metadata of images in DynamoDB, right? So these are some of the use cases where you can also store all these information into DynamoDB. Deliver seamless retail experience, use design pattern for deploying shopping carts, workflow engines, inventory tracking, customer profiles. DynamoDB supports high traffic, extremely scaled events, and can handle millions of queries per second. So that is why it makes DynamoDB so popular in the industry as well. Scaling gaming platforms, focus on driving innovation with no operational overhead. Build out your games platform with player data, session history, leaderboard for millions of concurrent users, right? Let me just adjust my camera here. So, developing leaderboards, right? For example, for a game, which user basically scored maximum points, right? All these amazing application could be developed on DynamoDB, as it can support massive amount of user, right? Concurrent user is fine, right? And also DynamoDB has their built-in cache called DAX, which we will again talk in future. DAX is a DynamoDB accelerator, which essentially further helps you when performing more read-oriented tasks, right? These are some of the customers that are using DynamoDB, that is Disney, Dropbox, Snapchat, and Zoom. Disney ingests billions of daily customer actions to improve their viewers' experience. Dropbox saves millions of dollars in expansion cost with a new storage system. Snapchat, all you know, I have also watched, this is my architecture. They store the metadata of an image on DynamoDB, and they have also developed an own, basically their database called SnapDB, which is built on the top of DynamoDB, right? So, all these amazing applications are powered by Dynamo. Zoom Video Communication Incorporation manages surge of 10 million to 300 million daily meetings participants. Maybe they're storing the metadata on DynamoDB. So all these applications are handling large amount of requests, right? So DynamoDB is designed, it is built for such sort of application, right? Let's understand the supported data types in DynamoDB. This is important for us to know. These are the supported data types in Python. You can Google for Java, for C#, but most probably they are same for all the languages. You have a string, you have integer, decimal, then you have a binary, you have a boolean, you have a none. None is essentially converted into a null, right? You have a string set. Sets are essentially called tuples, right? You have integer sets, you have decimal sets, you also have binary sets, right? You have an array and you have a map object. Array or list is called a lister. Dictionary is called a map object in Dynamo. So these are some of the basic data types that DynamoDB supports, right? String, decimal, there's no like float, it's called decimal here, right? Sorry, my bad, it's called number here. Sorry for the that. So you have string, you have number, you have binary, you have booleans, and by default your list and map objects. One of the perhaps most important topic in Dynamo would be keys in DynamoDB, right? It is very crucial that we understand what are the terms used in Dynamo. For example, partition key, sort key, GSI, LSI, and maybe how to design a simple tables, right? It's very, very important to understand these concepts in detail. So let's explore. DynamoDB has two keys in general. They are called as partition and sort key. What are they? Let's read and understand in detail. Partition key, a simple primary key composed of one attribute known as the partition key. Attributes in DynamoDB are similar in many ways to a field or a column in other database. Partition key and sort key are referred together as a composite primary key. I'll show you a demo and I'll show you what that exactly means, okay? So don't worry. This type of key is composed of two attributes. The first attribute is the partition and the second attribute is the sort key. All the data under a partition is sorted by a sort key. So basically partition will have multiple items. It's a partition, right? It will have multiple items, right? And you could filter from those multiple items. That is essentially sort key, right? You could filter the data you could filter the data when you retrieve the data for a given partition, right? Hopefully this will make sense for you. So for example, let's say I say, okay, give me everything for product ID 1. Now product ID 1 might have several books or they might have several data, right? You could filter on that data using a sort key, right? So here, let's read. DynamoDB stores the data in group of attribute known as items. Items are similar to rows or records. So we don't use the term row in Dynamo, we rather use the term called items. DynamoDB stores and retrieves each item based on a primary key value which must be unique. So if you have selected just a PK and if you're inserting data, then we expect that the partition key cannot be duplicate. But if you use the partition and sort key together, also called as composite, then you could have duplicate partition key. Now, let me explain you that when I use the word duplicate, right? I have a small demo on the next slide that I will show you. So please just hang on until then, okay? So for example, here, right? User ID 1, right? User ID has several orders, right? User 1 has several orders, right? So when you say, give me everything for user 1, you will get bunch of orders, right? Now I could essentially filter from that. I can say, give me order that begins with 1 or is between 1 and 4 or, stuff like that. So you could essentially sort the data. Once you get the data for a given partition, then you can perform sort operation on that, right? That's basically what it is. This diagram is a bit important to understand the internals of Dynamo. Items are distributed across 10 GB storage units called partitions. DynamoDB uses a partition key value as an input to an internal hash function. So what that means is basically, internally when you insert a data into Dynamo, it goes inside a hash function and Dynamo determines in which partition it should insert the data, right? So it's an internal hash function. DynamoDB does it behind the scenes for you, right? So here, as you can see, right, user ID 1 order, right? So now what is a composite key? When you are asked, you can say primary and sort key together forms a composite key, right? So the combination of PK and SK has to be unique. So for example, user ID 1, order ID 1. I cannot have user ID 1, order ID 1 again. It's a duplicate. That is not, you cannot do that, right? So a PK and SK combination has to be unique, right? While inserting data into DynamoDB, right? Let's move to the next slide. You can use operator like equal to, less than equal to, greater than equal to, begins with on the sort key. So for example, when you say give me all the orders for the user 1, right? Now you could maybe say, okay, give me the orders for the user 1 where the names begins with AT or AS or any letter or alphabets. You could essentially perform all the sorting operation after retrieving data, right? That is why we use the sort key in DynamoDB. So I hope these basic concepts are clear. Again, when we do some exercise on lab, and hopefully you will see all these in action, right? Now, this is important, right? In DynamoDB, a row size, or rather called as an item, cannot exceed more than 400 kilobytes. What does that mean? What I'm trying to say is basically a single row, in layman language, let's use the word row. A single row cannot exceed more than 400 kilobytes. If your item does exceed more than 400 kilobytes, a better way to store that is store it on S3 and have the key of an S3 in your Dynamo table. Again, this is one of the constraints of Dynamo, that is a single item size cannot exceed more than 400 kilobytes. Let's also talk about scaling in DynamoDB. On a broader aspect, DynamoDB offers two options for scaling, right? One is the on-demand mode and the second is the provisional mode. These are some of the popular interview questions as well. Hey, could you tell us the scaling options in DynamoDB, right? Now, to dive a little bit deeper inside these, right? What is an on-demand mode, right? These are where it is also called as auto-scaling in simple language. These are applications where you do not specify the WCUs and RCUs. We will cover what WCU and RCU means. So basically, whenever you're developing a new application, you do not know how the traffic would be, right? And the traffic may be a bursty in nature. Those are the scenarios where you could opt for on-demand mode, which means you will let DynamoDB do all the magic for you, basically scaling up resources, scaling down resources. You don't have to worry about that, right? So basically, mostly for new applications, right? This is a pretty good mode to choose for, right? So auto scaling mode, right? The second mode that we have is called as provisional capacity, and I'll talk about what that means. Here you determine how much capacity you want to set for DynamoDB, right? And once the capacity is exceeded, DynamoDB will throttle all your requests shall be throttled. So how does DynamoDB charges you money? So there's a concept of WCU and there's a concept of RCU. And let's try to read some technical definitions and then we'll try to explain you in a very easy way. WCUs, write capacity unit. Each API call to write data to your table is a write request. For items up to 1 kilobyte in size, one WCU can perform one standard write request per second. Items larger than 1 kilobyte requires additional WCU. So which means if I'm writing 10 kilobytes of data, I'm consuming 10 WCUs. This is the technical language Dynamo describes. So you want to say, if you're using 10 or 20 kilobytes or maybe 1 megabyte, you convert that into WCUs. That is the amount that you will be charged on, right? On other end, RCUs, also called as read capacity units, and let's read the definition again. Read capacity units, each API call to read data from your table is a read request. Read request can be strongly consistent or eventually consistent. Now don't worry what strongly consistent and eventually consistent are. We have that in the theory part, and then we have labs also for all these, so don't worry. For items up to 4 kilobytes in size, one RCU can perform one strongly consistent read request per second. Items larger than 4 kilobytes requires additional RCUs. So what they are saying is, let's say you read a data and you actually are reading 4 kilobytes of data. So that means you are charged, or they use the term 1 RCU to basically correspond 4 kilobytes of data. If I'm reading 21 kilobytes, I am essentially consuming 6 RCUs, which means you'll say, how is it 6, right? Shouldn't it be 5? So 4 5s are 20, and usually they round it up to the nearest one. So they will consume 6 RCUs in this scenario. So I hope the concept of RCU, WCU, provisional and on-demand is clear to you. These are some of the popular questions you might expect in the interview as well. What is a on-demand? What is a provisional? What is RCU? What is WCU? So I hope this makes sense. And now we shall cover further items from the presentation. So we did talk about provisional and on-demand mode in DynamoDB. There we essentially discovered a term called eventual consistency and strong consistency. What is these, right? I don't know, right? So let me read a couple of definitions and explain you what is a strong consistency and what is an eventual consistency. Again, if you want, you could go further in detail. There are articles that essentially describe the internals of DynamoDB. I do not want to go into that amount of detail, but rather want to keep it informative, right? When you are asked a question. Let's read the definition on basically eventual and strong consistency. Consistency model. Amazon DynamoDB lets you specify the desired consistency characteristics for each read request within your application. You can specify whether it's eventual or a strong consistency. Right? Now, what is this, right? Okay, let's read. Eventual consistency. The eventual consistency option is the default in Amazon DynamoDB, and the maximum and maximizes the read throughput. However, an eventual consistency read might not always reflect the result of recently completed write. Consider across all copies of data is usually reached within a second. It's very negligible, right? So what happens is when you write a data, so the data you write it basically goes to the router, and the router will route or basically first insert into the primary table, and your data is also replicated into different region, right? So when you are what happens when you're reading data at the same time? So what this says that if you observe, however, eventual consistency read might not always reflect the risk. So what they're saying is it might not reflect the recently data that you have written, because the data is still in the network. They are essentially being written into the replicated tables, right? Different region, right? So there you might observe a stale copy. Again, there are very less chance. All of this happens in a matter of seconds. The chances are very less. But I do want you to understand what is eventual and what is strong consistency, right? When you are asked. On the other end, let's read strong consistency. Strong consistency read in Amazon DynamoDB returns a result that reflects all the write that have received a successful response prior to a read. So whenever you read something, right, it will only return you data and make sure that. So for example, what I'm saying is whenever you write the data and the data is already gonna be written into all the replicated region, right? It will only give you a response when it basically has written in all the replicated region, right? So you won't be expecting a stale data here, right? Again, we'll read it again. A strong consistency read in DynamoDB returns a result that reflects all writes that have received a successful response prior to a read. So, right, to get a strong consistency read result, you can specify an optional parameter in the request. It takes more resource to process a strongly consistent read than an eventually consistent read. So this is also a trick question here, right? So they might ask you in the interview, okay, where can we save money, on strong or eventual consistency? You can say you can save money in eventual consistency, right? You can save money there because if you observe here in eventual consistency, and I'll try to highlight here, the eventual consistency option is default, right? That's the default one. The read might not always reflect the result of the recently completed writes, right? This is important. On the other hand, strong consistency will take additional resources, but it will ensure, if you observe, read in Amazon DynamoDB returns the result that reflects all the writes received a successful prior read. So again, this is important for just to know for the theory part, right? What is a strong and an eventual consistency, right? In strongly consistent read in Amazon DynamoDB returns result that reflects all the write that have received a successful response prior to a read. So right, so again, depending upon your use case as an application, you can either go for strong or eventual, but by default eventual consistency is the default option. Okay, and if you want to go for strong consistency, there is an option parameter in Boto 3 or whatever library you're using, and you can easily configure that. All right, so shall we learn more about the GSI and LSI now? So let's get started. So these are some of the very important concepts in DynamoDB, and I request you to practice these concepts. GSI and LSI is everything that you need to know, right? Because a lot of time when you are modeling data, you will require several GSI and LSI, right? So hence, let's understand what is GSI and what is LSI, right? So let's get started, right? So the first is GSI. The GSI stands for Global Secondary Index. Now, as you remember in my previous classes, and I'll just refresh your memory here. So here, not this slide. So let me go a little back. Here, right? We had a partition key and a sort key, right? So I could say my access patterns are like, hey, give me everything for a user 1, right? Give me everything for user 1 where order begins with or order is greater than 3, right? I could do all the filter options, right? So what is GSI? Why do we even need it, right? So let's read and then understand a little bit, okay? First the definition and then the example. And again, we have labs for all of these, okay? To illustrate, consider a table named game score. Let me make sure. I think my slides are, I think my slides are upside down. Or is it? No, it is fine. That's fine. So to illustrate, consider a table named game scores that tracks the user and scores for a mobile gaming application. Each item in the game score is identified by a partition user ID and a sort key game title. So your access patterns are basically, and again, these images and all of that I've taken from the article. All the citations are there. So if needed, please go and read more about that. Okay. So let me zoom in to my diagram here. Okay. So what they are saying, let me give 1 sec. Sorry about this. So, okay, so my access patterns are okay. Give me everything for a particular user, right? Give me all the game title for user 101, right? Give me everything for user 101 and give me items where the title begins with ST in the beginning, right? Or G in beginning, right? So these are my access pattern, right? My primary and sort key. Now say what has happened is basically, let me explain you here. Suppose that you wanted to write a leaderboard application to display the top score for each game. So what we are saying is now based on this data that we have, right? So again, what is our primary key? User ID. What is our secondary key? Or game title, right? So now you want to basically get the top score for each particular game title, right? So you would think like, okay, well, I could just run a scan query. Scan in Dynamo basically would go over all the rows. Basically, it's think of this as a for loop. It's an O of n, right? It will go across all the items in Dynamo, right? But that's not efficient, right? As the table grows, it will become more slower, more inefficient, and so on, right? So what do we do? Wouldn't it be better if I could query based on the column called game title? That is exactly, guys, what GSI does, right? So that is the goal of GSI, right? So basically, to explain you, GSI allows you to have a different partition and a sort key. So I have explained this in the black diagram here. So now I could say, for example, my access pattern here would become, just want to show you here. So here I can easily say for my game title Galaxy, let's say for the game title Galaxy Invader, find a max on top score, right? So I could run a sort command on my top score, right? So my secondary key would be top score. So now I can easily find who are the user who has top scores for a particular game, right? I could run all these items pretty easily. So all you need is something called GSI for your application, right? So GSI essentially allows you to query your data by having a different partition and a sort key. So your game title becomes a partition, and now you could run filter or sort your data based on the top score, right? So GSI helps you to set a different partition and a different sort key, so you can query your data more efficiently rather than a scan operator. Each table in DynamoDB can have up to 20 GSI. Again, this is an interview question. They will probably ask you, right, how many tables we can, how many GSI we could add on a DynamoDB? The answer is 20 GSI per DynamoDB table. Now let's understand the concept of LSI in DynamoDB, right? So we did, let me fix my camera. I always have a problem. So what is LSI, right? We understood GSI, right? We know primary, we know secondary. Now GSI allows us to have a different PK and a different SK on a column. What is LSI and why do we need that? Well, a lot of times, again, I'll read definition and then we'll, see a small demo. Again, here is the reference. Some application only needs to query data using a base table's primary key. However, there might be a situation where an alternative sort key would be helpful to give your application a choice or a sort key. You can create one or more LSI local secondary index on Amazon DynamoDB table and issue a query, an issue and query or a scan request against these indexes, right? So what is the use case is basically, say we have this table, right? We have forum name and subjects, right? So here my access patterns are, I could run queries, for example, give me everything for a particular forum name, right? Give me everything for a forum name S3 where the subject begins with ABC or XYZ. So I'm running my sort operation, right? But what if you want to add a next access pattern on last post date time, right? So for basically I want to say, okay, give me everything for a form S3 where date is like 2015-01 or 2020 for a particular year, right? So you want to query on the new column, right? In those scenario, you can use an LSI, right? LSI allows you to have a same partition key and a different sort key, right? So now you can essentially efficiently filter on that column if needed instead of doing a scan query, right? So here I'm demonstrating you, right? So here I'm showing you SK. So the same PK, but a different SK, right? So that is nothing but an LSI, right? I hope the concept of LSI is clear. Let's review or refresh the memory from GSI and LSI. Very popular question always in the interview, right? So GSI allows you to have a different PK and an SK. LSI essentially uses the same PK but a different SK. You can use up to 20 GSI per table. You can use a maximum up to 5 LSI per table, right? For tables with LSI or local secondary index, there is a 10 GB limit per partition key value. A table within local secondary index can store any number of items as long as the total size for any partition key does not exceed 10 GB. Very important, okay? So I hope these concepts are clear about the GSI. All right, let's perform a small data modeling exercise in DynamoDB. If you want to further read about data modeling in DynamoDB, I have a link on the slides. You can go and read more. We'll be focusing on one-to-many. How do we model that? Author Alex Debris has given 5 methods or strategies in which you could model. We are going to discuss the first 2. That is denormalization by using a complex attribute and by duplicating data. So here there's a classic example that you have a customer, right? If you observe here, you have a customer and then you have an address table. A customer can have many addresses, right? So as you can see in traditional relational database, you will have a customer table and an address table. And if you needed, you could join on a PK and a foreign key, right? That's how you would do it, right? Now, the way you do this in DynamoDB is by this way. So here author Alex says, see, he's using a complex attribute to demonstrate or to represent the many part. So here is my first name Alex and my last name is Debris. So my PK would become my first name and my last name would become Debris or whatever that is, right? And here you can see now we are representing the many addresses, right? So the home address, the business address in a map operator, right? So essentially many part, right? So if needed, if you have one to many and if you would like to model that, here is one of the ways in which you could model it by using denormalization using a complex attribute as showed by Alex Debris. You can read more on the link or the article below. I'm just showing you an overview, right? The another way here the author explains is by duplicating data. So how does this works is if you observe, this is a classic example of an author and a book, right? Authors can have several books. Each book is associated to one or more authors, right? So how would you model this? So if you observe the model here, oops, sorry. Let me go down. Trying to go down, but all right. So if you hopefully guys can observe this, right? So the author name becomes my primary key and the many attribute here, that is the book name, right, becomes my secondary key, right? So essentially now my author has many books, right? Each book has a release date, etc., further items, right? So you can use a sort key with the primary key to essentially model one to many, right? So here a single author may have many books, right? Now if you have access pattern that you want to query based on the book name, you want to get author. Now how would you do that? Answer is GSI, right? So you could set up a GSI and you could query basically the author name based on the book name. You could set up that, but again that depends upon the use case and the access pattern, right? I encourage you guys to read further at this particular blog post and I'll provide additional resources as well. So here we can conclude all the theory aspects so far. Now let's jump into the most exciting part, that is labs, hands-on session. So let's get started with let's get started with the lab session, guys. I'm excited. So the first lab is essentially how we can create DynamoDB table using a serverless framework. So I'll show you and I'll show you the code and then we'll try to read this. So service is basically we are providing a name. Think of this as an alias for the project. So we'll say so I'm just calling learn DynamoDB. Here I'm defining a frame. I'm using a serverless framework 3. Here I'm saying provider is AWS tags. I'm providing tags here. Tags are a great way to monitor the cost. So I would encourage you to use the appropriate tags. .env as true, which means I have an env file and I wanna inject the values here. And here I'm creating a resource object, right, called as my table. And here I'm saying type as DynamoDB table. This means that I want to create a DynamoDB table. Then we have an attribute called property, and now we are defining our table name here, $env : table name, which means from this env there's a variable called table name. Inject that into this here, right? We have an attribute here. I'm simulating a very simple scenario, one to many, that is a user has many orders. So my user becomes a partition key and my order becomes a sort key, right? So I am essentially defining my attribute definition, and here you can see here is my key schema. I'm saying the user ID is going to be a hash and the order ID is going to be range. So this is essentially a one to many. We'll populate the table shortly. Billing mode means DynamoDB has two scaling option, remembers provision capacity and on-demand mode, right? Provision means you as a user will specify the WCUs and RCUs. On-demand means AWS will automatically scale the resources based on the need, right? Table class, DynamoDB has recently released an infrequent access, which means you can save up to 60% on the cost on the DynamoDB table if the data is not frequently used. It's simply like a storage class on S3. Point in time recovery means that on an incident, whenever something is deleted or failed, you could easily restore your DynamoDB tables from backup, right? That's pretty much it. So let's head over to the project directory and then issue the command sls deploy. This should deploy our first DynamoDB table, and then I'll show you how to query that, and all that stuff will be coming soon, right? So now, as you can see, it's creating my cloud formation stack, and let's wait for this to be deployed. Again, these all labs are there, so I encourage everybody to download the labs and try this out. So pause the video and try it out, okay? So I'm gonna wait until and unless this resource has been created, right? And I'll head over to my management console, and here you can see on the dashboard I do not have any table at the current moment, right? So let's wait. Still deploying, and at this point this should be pretty much done, and I should see my DynamoDB table on my AWS account, right? So let's wait. I shall not be editing the video, so I want to keep it raw, so feel free to pause the video or fast forward the video if needed, okay? And all set, we got the check mark here, and now let's come here, click on tables, and guys, congratulations, we have our first DynamoDB table. Now I'm assuming you guys are a complete beginner and you are seeing this screen for the first time, which is why I will be walking you over the navigation shortly. Here is a table option where you will see all your DynamoDB tables on your account, right? Then here you have a high level dashboard, which you will see on a high level if there's an alarm or DAX, which I don't have any at this current point. ParticleQL is a new editor which allows you to query the DynamoDB table with a standard SQL. Backups, if you have any backups, as you know, I do have backups from my past projects, so these are those backups, right? So you can restore your DynamoDB tables if accidentally deleted or something, right? You could restore from the backup. Export to S3 is a feature where you can export the data from Dynamo to AWS S3 in Dynamo JSON format, okay? Then we have a new feature, and I have talked about this repeatedly. It's called import from S3. This allows you to import data from S3 into DynamoDB, okay? A reserved capacity, again, if you want to reserve RCUs and WCUs, so those are here. Settings here is simply a view, whatever view you are more comfortable with, right? So now let's head over to the table section. This is a hyperlink. When you click on the name, this will show you all the items for that particular table. Here you have a tab which will allow you to navigate. So the first tab is the overview. This gives you what is your partition key, what is your sort key, what is your capacity. Here you can see on demand, auto scaling, right? Shows your status and your alarms if you have any, right? These are just additional info which I'm gonna ignore for now. Here you will see all your matrix, right? I don't have any matrix at the current point. If you want to get the count on the table, you will click this button and this will give you the count. This section is for the GSI. Remember in my class I told you about GSI. GSI allows you to have a different partition key. Again, monitor section for further monitoring. Global tables, we'll cover this shortly in the upcoming session. To create backend with active multi-region model, we'll use a global table. Backup, if the table is accidentally deleted, automatically you could restore it from the backup. Is a feature called PITR, point in time recovery. And finally, these are all the settings for streams and exporting data and stuff like that. All right, so let's click on the explore. We don't have any data yet. Let's try to publish data to dev.user. So I'll head over to my code. This is lab 1. And again, all the code, you should be able to find it here, right? So now what we are doing here is I defined, first of all, do a pip install DynamoDB. We are going to use a library called DynamoDB. So I defined a class. I defined my schema here, user ID as a hash, order ID as a range, which is one to many. A single user can have multiple orders, and first name, last name. And here you can see I'm essentially uploading 100 of fake data. So let's try to run this code and see if we are able to populate certain record about 100 items in DynamoDB. And then I'll show you the UI, how we can query this, and etc, etc, etc. And let me add one particular line, that is response, so that we could see this print response. All right, I will be calling this main function in __ name. All right, so let's run the code now. Again, this should populate my DynamoDB table, and I seems like I have an error, which I will correct shortly. So here we have table dev.user when calling put item operation number value cannot be converted into string. Okay, that makes sense. Here I've defined this as a string, and maybe I'm passing an integer. Absolutely right. The order item is a string. So what I'll do is I will be using a dunder_str method, which will convert my data attribute into a string, and I'll do that on all the columns, right? Now let's try to rerun, and hopefully this issue should be resolved at this point. And here you can see I'm consuming WCUs and RCUs, so it's done. Now if I simply click run, I should see some data. If not, then click on tables, then simply click on here and then explore table. Now I should be seeing some data here. Looks like there is a small delay. Yeah, there you can see. Now I have all my data attribute. Let me minimize my camera here. So as you can see now, I have a user. Each user can have several order ID, right? And here are their names, right? Again, these are like fake data. How do we query this data? I'll teach you both from the UI and DynamoDB, right? Say I want to get all the data for user 2, right? So you can come here, select the table, and you can say, give me items. We don't call row here, we use the word item. Give me item with the user 2, and you will get all the items for user 2, right? That's absolutely great. Now say you want to sort the data, right? So that's when we can use the sort key. This is our sort key, order ID. So let's say I'm looking for order ID that is greater than, let's try a greater than. So let's use greater than equal to 20, and we can run. And here you can see I got all the order greater than equal to 20, right? Similarly, you can use any of these operators that are available. For example, equal to, less than equal to, less than, greater than equal to, greater than, between, begin, right? So all of these operators you can use. So I can even use, I want to see the order ID between 20 and 40. So filter that for me. And sure enough, this works absolutely fine. So I have just showed you how to query the data from the console, right? Now let me show you how to query the data in DynamoDB. So I'll be walking you over the steps now how to query this data in Python. So let's see how to query this data using Python, right? So let's head over here, and let's define a function called query, right? Now actually it is very easy to query the data. Since I have the class here, right? And I also have some snippets. I'll try to copy paste to save some time here. This is from my previous blog article, right? So for example, if I want to query, let's say if I want, we have already seen the insert statement, so there is no point to do that. Let's do a query, right? So we'll write our first query. So the way you query the partition key, right, is basically you take the user model and use the word query, and I'll show you shortly. So we're going to write the same query, right, where the user is 2, and let's say then we want to sort it, right? So here I will say my user is 2. By default it runs on the partition key, right? And then I will try to run this object email. There is attributes to it, right? I think there is one called toJSON. Yeah, there is one called toJSON, right? So let's try to run this, and I need to call the query method here. Again, this will return you a paginator object. So it's an iterator, right? You can iterate over the data efficiently, right? You could easily do that, right? Now I think you can also query by sort key. So now you can say my first name starts with or greater than, right? So here I can come here and say, let's say my sort key was order ID, right? So I'll say order ID Let's see what all operators are available. Yeah, between, so we'll do 20 and 40. Let's try to see if this works. So I should see the data. So this is gonna query the data. It's gonna go and get the user ID too, and then essentially apply a sort method, and sure enough, this works, right? So I hope this makes sense. This shows you how to query this data, both in Python using DynamoDB and also from the console or the UI, right? So now let's learn and explore the concept of GSI in DynamoDB a little bit more in detail by performing a very simple lab, because we understand better by actually performing or doing labs. So I'll be showing you both how to create those GSI index using Serverless Framework, and then how can we query through UI and through Python code as well. I saw so many Stack Overflow people have been having a hard time with that. So let's learn a little bit, okay? So what is the concept here? We are essentially simulating a very simple scenario here. A user has several products, right? User like product 1, product 2, user 2 like product 1, 3, 2, and so on, right? So my access pattern here is, for a given user, give me all the products, right? For a given user, give me a product 1, right? You can say equal to begins with all the sort operation. So this is my PK, this is my SK, right? We all know that. Now say you have a feature, you need a new feature where you need to see for a given product, who are the users who are interested in that product, or who like the order, or essentially who ordered that product, etc., 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 right? So, well, scan queries, you can run a scan query, but that's inefficient. That's gonna scan the entire table, and as table grows, very inefficient. A better way would be to set up a GSI. What if I can set up this as a PK and this as an SK? So now I can say for my product 1, give me all the users, right? So let's learn now, okay? So we know the concept now, right? Again, a little bit theory without going too much crazy. GSI allows you to have a different PK and SK. LSI allows you to have a different SK and the same PK. Maximum 20 GSI per table, maximum 5 LSI per table. All right. So let's get started with the exercise. So here we are saying defining the service, the framework, the provider, and the .env. Here is where we create the table. So here I'm saying table name is equal to $env.table name, which means I have a file called env, and from that use the variable value whatever I have provided, right? So attribute definition, I'm saying user ID and product ID. These are my two attributes, right? And key schemas are basically as follow: user ID as hash and product ID as range, as shown in my Excel sheet here. Okay, so this should be pretty much clear. Billing mode is paper request, which means we are using on-demand mode. DynamoDB has two modes, on-demand and provision. We are using an on-demand mode here. Table class is standard. DynamoDB offers an infrequent access as well, which means you save 60% on the cost. But for this example, I'm using a standard class. Point in time recovery essentially allows you, if the table is accidentally deleted, it allows you to recover your data or essentially back up your, restore the table, right? That's what it means. And here is the magic, that is a GSI. Here we are saying that we want to create a global secondary index. The index name would be product ID. That's my hash key, and followed by my sort key, and I'm using the word index. Here I'm defining my index here. Those are the key attributes, right? Attribute product ID and attribute user ID. So what I'm saying is here, this is my normal PK and SK. And now I have a further access pattern where I want to query on my product ID. So hence I set up my product ID as my PK and user ID as my SK, which is what you see here. You can add up to 20 GSI per table, right? Projection all means project all the attributes here, right? So now we come here to the lab. And I have already deployed this in advance. So you can say SLS deploy, and this will essentially deploy your entire stack. And again, I have already deployed it, so it might give me an error, right? So once you're done that, this will essentially create a table for you on the cloud. So over here, this will create a table called dev.user.products. Okay, so this is a table. Now we need to populate that. So again, as you can see, I already have a table. Now we need to populate the table with some dummy or fake data. So what we will do is you will call the function called populate tables here and run the Python code. This will populate the table with some dummy data. I've already done that. I already have some data here, as you can see. If I can show you here, I think I have about 100 samples here. So if you come here, explore, I already have about enough data here for my exploratory purposes, right? Let me just do a scan here. Right, I have a lot of data already here, okay? So now I'll show you how to query, right? My first access pattern is the query, right? So for a given user, give me all the products or fetch all the product, right? So we'll say we'll use the first one here. So we'll say for a given user, show me everything. So these are all the products for a given user. If you know which product you're looking for, you can use a sort key to do a filter, right? So you can say product ID is equal to this one, and it's pretty fast. It's very fast. Now you have a second access pattern based on the GSI. So now on the drop down, there's as you can see, there's a GSI called product ID. So now I can do the reverse, right? So I can say for product ID 2, give me all the users, right? So I can run this, and here you can see for product 2, there are user 1, 2, 3, 4, 5, much more efficient, right? All right, so this makes sense to the UI. Now if I want to fetch the user, or I want to do some filter operation, I can use my sort key to do the filter, right? Now, how do I do that in the code, right? How do I write the Python code? Well, okay, let me show you that. So the first, I'll show you how to query regular, right? So what you want to do is, I have defined the user model here. Here you can see my table name, AWS access key and secret ID. These are my schema, user ID as hash key, product ID as my range key. And now if needed, I can run saying that user model.query, give me, so what I'm saying here is give me everything for user 2, right? So again, if you want, you can further run the sort operation, right? So for example, really quick, I want to show you. So this will query based on my PK now, right? So I'm saying for, sure enough, it works, right? So I'm saying for basically a user 2, give me all the products. So these are all the products, right? You could run a sort query, begins y equal to, etc., etc., etc. Now, how do we query GSI? That's the tricky part where I saw like people were struggling, Stack Overflow. I was like, okay, let me make a video. So the way you do that is, first you need to define a view index. So observe how I'm doing it. So view index, I'm inheriting this from global secondary index. I'm providing a meta class where I'm providing the index name, projection as all, and I'm providing my AWS access and secret key. Here I'm only giving the attribute that is my sort and my hash key. So here I want to query on user ID and product ID, right? So my product ID is the hash key, right? And my user ID becomes a secondary key. Again, based on the Excel sheet that we just saw, right? Hopefully this should make sense, right? Now, what we do is we again make a model. You can name it anything. I just named it test model. This will inherit from model. And here you will provide a meta class, and you will provide the base table name. And then here you will essentially give all your attributes that you have on the table. So I know I have user, product name, and description. Now to query GSI, you will use this class and not the view index, okay? A lot of people are confusing on this, right? So now if you observe my query GSI, so here you can see test model.to. So what this is gonna do is basically for product 2, give me all the user, right? So if we run query GSI function, and if I simply run the Python code, you should see all the user for that particular product here. Again, these are all the users, right? Works fantastic. You can use .toJSON method, or if you just want to fetch a particular field, you could also do that by just using the dot operator. Let's say I'm interested in the user ID. So you could say .user ID, and this will only fetch those particular user or those particular attributes, right? So here you can see works fine, right? So yeah, this is basically all about GSI, a small lab about GSI. I hope your concepts are cleared, right, about GSI. We'll explore LSI in the next lab, right? So again, just a refresher, right? Again, this is an article this is the image that I've taken from AWS. Same concept, right? User have several game title and top score. So here the access pattern is, okay, for a user, give me the game title. For a given user, filter on game title, right? So what if you want to implement a leaderboard, right? For example, I want to see which user scored maximum score for a game, right? So in that scenario, I want my game title to be my PK and my user ID to be my SK, right? Or my top score to be SK, so I could filter out, right? So that is exactly what the this author shows in the blog post, right? So now I can say for a given game, that is Galaxy Invaders, right? I can grab all the scores, right? I could essentially get the max, and I could see which user was that, right? So a leaderboard, right? So I hope your GSI concepts are clear with the simple lab. If you enjoyed this video, make sure to give a thumbs up. And now in the next video, we'll see a lab on All right, so let's understand and explore about LSI with a simple lab. So let's get started. I have a very simple lab here. So the use case is basically pretty simple here. A user has several products, right? So here my access patterns are: give me everything for a user, give me everything for user one and product one, right? I could use the sort key to filter greater than equal to, begins with, etc., etc. Now say these products have grown a lot, right? So these tables are massive now, right? So one way, for example, if I want to filter based on the total amount, right? I either run a scan query, or once I get the data, then I can, grab all the objects and then filter it out, right? But a better way would be if I could directly use a sort key here, right? That is nothing but that is same thing what LSI allows you to do. LSI stands for local secondary index, that essentially allows you to have the same partition key but a different sort key. All right, so let's see a small demo. Let me show you. So first we'll see how we can create a simple table and then learn to query these items. Okay, so here I'm defining my let me make sure I'm not yeah, that's fine. So here we are in the lab 3. I should have said this lab 3, unfortunately, but that's fine. Framework, we are providing the tags for better visibility on the cost aspect. We're using a .env, and then we are defining our resource object over here. We are saying DynamoDB table because since you want to spin up with DynamoDB table, here is the table name. $env means that there's a file, env file I have, and the value of this variable shall be injected. So if you observe, I have my attributes here. I have 3 attributes defined: user, product, and total amount spent, right? So again, simulating the same scenario here, right? So they all are string, and then in the key schema I defined user ID as hash and product ID as range. So simple. This is my PK, this is my SK so far, right? Now billing mode is an on-demand mode, and I'm using a standard class here, PITR. I've enabled that, and here I have a LSI, also called as local secondary index. So if you observe, I have the same PK. I'll show you. So I have the same PK. User ID is going to be my hash, and my sort key here becomes my total amount spent, right? So if I want to filter on that particular column, I could essentially do that, right? So I have defined my sort key, my PK and SK, and I've defined my index name. And now what you need to do is you need to come here to lab number 3, open this in terminal, and issue the command serverless deploy. I have already done that. I have already populated the table just before starting the video. Now we need to populate the data. We need to populate the table with some fake data. So run the function called populate tables. This will generate the table or populate the table with some fake data. Once you're done with that, now let's try and understand how to query this data. So I'll come here, dev.user.product, click on explore, and here you see I have all the data, right? So the first thing that I will show you is let me just run a scan first, and then all right, so here you see I have all the various user ID and the products, right? So now what I want to show you here is the first thing is a very basic query. So for example, my access patterns are for a user, give me fetch everything, right? So I can say for user 1, fetch me everything. So here you can see for that user, it did fetch indeed everything, right? Now the next access pattern here, sorry, slip of tongue though, but the next access pattern here is for the user 1, give me, let's say, product 10. So you know exactly what you're looking for, and then sure enough, you can use the sort key to filter out. Wait, did I? Oh, sorry, the user 1, and here that becomes 10. So in this case, I exactly know what I'm looking for, and hence I was able to find that relatively pretty fast, right? Now let's understand the concept of LSI here, right? So again, running the scan query. So now what I want to do is basically, I want to get everything for user 1. So we will select the drop down, and I'm going to select the LSI. click on query, and we click on this drop down. So now I'm doing the same thing here, right? For the user one, fetch everything, right? But now since I have LSI, look here, I can filter based on my column, this column, right? So essentially allows you to have a same PK and a different FK and different SK. So here I can say, okay, give me everything for user one, but filter out items where the total amount spent is greater than $5,000 or 3,000, whatever that is. Again, I think 5,000 and more is not there, so I'll use 3,000. Oh, I'm using an equal to sign. I should be using greater than equal to. Let's try this. And sure enough, you have it, right? So now I can even use 5,000 here. And sure enough, it works fine. Now let's understand how to query this in Python. Again, this is relatively easy, right? I will point out one thing. There's a small glitch I have observed in the DynamoDB library. Again, if you guys know how to resolve it, let me know in the chat box, okay? So first is a very easy one. So here you can see I'm defining my index. That is called a view index. This inherits from local secondary index, right? And here I'm saying my index name and my projection. Let me also give my access key here. Give me one sec. Okay, so here I'm gonna provide, oh, I already have it. I thought I didn't have it, but okay. So here if you observe is I have a view index which inherits from local secondary index. I have a simple class meta. These takes following attribute, the index name, the projection, access and secret key. Here is the index that I showed you on the UI, right? And here I'm defining a user ID is my hash key, my total amount spent is a range key, right? So I define my index here, that is a view index, right? And now I define my model LSI, user model LSI, which inherits from model. Again, I give the table name, access key and secret key. And here is a small glitch I have observed. Ideally here, this is where I should be saying the range key. And I'll show you the glitch that I have observed here. So the normal query works fine. So for example, give me everything for, so I'm querying the LSI index, right? So this is the one that I am running the query on, and I'm saying give me everything for the user one, right? So if we try to run this code, looks like I was populating the data again. So let me run query LSI, and then again let's try to run this query. And basically I'm querying on the LSI index now. Okay, so I should see all the data here, right? Now what I've observed is a small glitch in this is it's in the library, I guess, but I was trying to do a filter command and essentially it didn't work. So ideally I would say, you know, based on the documentation here, you will say user model LSI then you would specify the field name, and then you can say, you know, greater than, for example, greater than, let's say 5,000, right? So if the moment I specify a sort here, the code fails and the LSI gives an error. And this is something on the library side, and as you can see, right, it's something on the library side that I have observed, right? And I was looking into the solution casually, but I think a lot of people were facing these issues, right? So if you know how to resolve in DynamoDB, let me know. But this is something that I have personally observed. So while using DynamoDB by querying LSI, okay? Again, same thing. If I try, again, I tried because I know this works, so I can say between queries. So let's say between 1,000 and let's say 6,000. And remember, in my previous labs, I have used GSI, so I did use this syntax to query data. So if you observe, I was able to query, you know, the GSI here, and I was also able to do the filter by command here or the sort command here, right? But on the LSI, on this DynamoDB, I had some problems, not sure why, but let's try to run this. Again, you will run into an error, so just do keep in mind if you run into issues, right? So don't spend too much time. If you want, you could essentially create a post on Stack Overflow. But again, I was also looking into this, why it's failing, right? So I came to this blog post, but I'm not sure this really helped me, or neither this, and this. Because if you see the official documentation here on DynamoDB here, so the way they explain is, see, if you observe here, we create a class, we create a local secondary index, right? Same thing, right? We did that. Then essentially while querying, we specify the model. So this query works, right? The problem is while using a sort command, right? So here you can see greater than 0, and this is where it throws a error. So just do keep in mind that there's a small glitch there, okay? All right, so I hopefully this video was useful. I'll leave the source code here for the lab 3 in the description section below. So if needed, you guys can check that out. So this is about LSI, and now in the next video we shall learn about PITR. So for example, let's say accidentally I delete a table, right? How do I recover it back, right? So let's understand that in the next. So let's understand PITR in DynamoDB, right? So for example, let's say this table, right? Somebody went in and basically deleted the table, right? So assume somebody went in and deleted the table, right? What would we do now, right? So in order to prevent from scenarios like this, right, PITR helps you to back up your data continuously and essentially do a restore whenever incident like this happens. So now here you can see, since the table is deleted, but since I had a PITR, I could easily restore it. On CloudFormation, while creating DynamoDB table, they just call point in time recovery specification, and you can enable this by setting the attribute to true. Once you do that, now it's absolutely piece of cake. Now, as you can see, I can come here, right, and I can click on restore, and I can say, I can specify my table name, right, and I can say restore the table without secondary index, or I want to restore the entire table. I can click on restore, and there you go, your table will now start restoring, right? So hence, understanding all the best practices will always help you to prevent from scenarios like this, right? For example, any interns, maybe having production access, again, like I said, maybe, or any junior engineers that are doing, right? They went in, they accidentally deleted, and now suddenly all your apps are down, all your customers that are using those tables are messed up, right? But having these backups help you to essentially protect from these sort of scenarios, right? So I encourage you guys to do a PITR always when creating a DynamoDB table, and also if needed, you could also click on schedule backups. That's also a pretty good way. And if needed, you can always say export to S3, which will push all the Dynamo data to S3, and if needed, if an incident happens, you can always restore it back from S3 as well. There's a new feature called imports from S3, right? So I hope this was useful. It's very important to have point-in-time recovery, PITR enabled on your DynamoDB tables. All right, now the next 2 labs that we have here is essentially pre-recorded. It's already there on my YouTube, but I'm simply gonna insert that here. The lab essentially that we are doing here is how do we essentially populate the data lake in real time whenever an item is inserted or removed from DynamoDB, or essentially archiving architecture on DynamoDB. And the second lab will be talking about powering downstream user through DynamoDB streams. So we'll capture the stream events through Kinesis stream. Through Lambda, we're gonna transform, and then we're gonna essentially relay those events back to an SNS topic where we could fan out for multiple subscribers. So let's learn more about those. This is a project, a hands-on session where we're gonna build a very, very interesting item. We are about to build real-time data archiving architecture on AWS that is essentially anytime any entity essentially goes into Dynamo, whether it's essentially create, update, or delete, we are gonna stream those events through Kinesis data stream, and then we are gonna fire Lambda function. The Lambda functions are gonna process these data from the Dynamo. It's gonna normalize the data from Dynamo JSON to a standard JSON. Then it's gonna dump on the data lake in the year, month, day format. And then we'll see how to query this data using Athena. And all of these happen near real time when I enter or delete record. Not only that, this project and lab also has infrastructure code. So everything is there. And as I said, this is not a beginner level lab. You need a little bit background on AWS. So let's get started with this video. All right, I'm excited to show you. Again, the code is pretty big. And again, this is lab number 24. So again, you should have all the code here. So do not worry about that. So let's go from top to bottom, and then I'll try my best to explain. Again, there's a lot of code that I need to explain. This is essentially declaring the serverless framework. Over here, I'm just declaring my stack as AWS, runtime, memory, timeout, architecture, and basically some tags. I'm using a .env. I will cover this part in a later, but I want to cover these items that I have. The first thing that I need is an S3 bucket where I will dump my data. Basically, whenever I insert or update or delete anything, I want the data to go to the data lake. So I'm creating an S3 bucket using a resource object here. After that, what I am doing is I'm creating a Kinesis data stream. I'm using an on-demand mode, and as you can see, $env variable name means that this value is essentially injected from this particular env file. Don't worry, I'll delete all the keys, so not to worry about that. Again, there's a lot of code, so let's keep going. So this is, I'm creating my Kinesis data stream. Now here is where I'm creating my DynamoDB table. I'm using a resource object. I'm saying Dynamo table, providing the name of the table and attribute primary and secondary key, whatever you guys have that. I'm defining my schema, range and hash key. This is on-demand mode, which means I am not specifying WCUs, RCUs. I'm using a standard class. Dynamo also has infrequent access. I'm using also PITR, which means point-in-time recovery, backups, right? I'm doing that. And if you observe, Kinesis stream specification is equal to getAtt is a function which is gonna get the ARN after the Kinesis data stream has been created. Again, so what we are building is essentially, if I had to show you here, we have this user, he's gonna insert the data into DynamoDB, and we are essentially real-time streaming this data through Kinesis data stream. We are firing Lambda function, and this Lambda is essentially going to the S3. All of that is happening real time. And from here, we essentially have our Athena, where our end user is gonna use ad hoc queries to query my data lake. And then you can build the dashboard using AWS QuickSight. That's the entire full-on stack, okay? So here is our all infrastructure code. Hopefully that makes sense. Now I would go to the Lambda function on what I have done in a second. So the first thing that happens in the Lambda function is I iterate over the Kinesis data record that I'm getting. I essentially take the payload, I decode the payload because the data that comes from the Kinesis data stream is encrypted and it's a base 64 string. So I'm decoding the string, and then I'm deserializing my string using the loadS method. Once I have that, I'm checking the event name in the Kinesis payload, right? And I'm saying if the payload is insert or if the payload is remove, do something, right? So basically the CRUD operation. So as soon as, let's say the payload is insert, I essentially take the Dynamo object, Dynamo JSON, and I'm essentially, if you observe, I'm just storing this in a variable called JSON data. At the end of my class or at the end of my function, I'm here saying JSON data if it is not none, which means if I was able to get the Dynamo JSON, I'm using an unmarshal, which is a function which will basically deserialize my Dynamo JSON to a regular JSON. So that happens, and then I'm adding certain meta fields, for example, region, event ID, event name, and event source. And at the end, what I'm doing here is I'm creating my data lake, year, month, day format, and finally I'm inserting the data into the data lake, and I'm also printing it. That is basically the Lambda. Again, now I'm gonna show you by deploying the entire stack. So I'm saying SLS deploy. This will deploy my entire stack, including DynamoDB, Kinesis data stream, Lambda function. All of that is being deployed with a single click. Since I've already deployed, I'm getting a message, no changes to deploy, deployment skipped, which completely makes sense. Now, let me show you the demo. This is really interesting, to be honest. So I'm gonna create an item and I'm gonna say, hello. And truly, this is fascinating to me. Like, this is happening real time, okay? Ready? 3, 2, 1. So I have inserted the data into this table, right? Dynamo table. What happens is now in near real time, it's gonna go to the stream passes to the Lambda, and essentially what I wanna show you, and remember there's only one item. So if I query this again, should be there in a couple of seconds. Guys, look at this. This is absolutely flawless. We got that somebody inserted into the data lake. So as soon as there was an insert in Dynamo, we near real time are streaming those events. And as you can see, year, month, day. Of course, we have the field, PKSK, and the region and the metadata. This is flawless because think about it. Now your DynamoDB can have operational data, and all these data can accumulate over the time in the data lake, 10 years, 20 years. You could load this data into a warehouse now, data warehouse. You can perform OLAP queries on this. So this architecture is absolutely flawless and works without any problem. Entire code with CloudFormation and serverless is there in the description, which is called lab number 24. If you do enjoy these tutorials, please give a like and a simple comment saying that, hey, great job, would be really amazing, because it takes a lot of effort to write code, to compile everything and compile in a short video for everyone. So a simple like and a share or a comment would really make my day. And by the way, this is a flawless architecture, widely adopted. We are also adopting this architecture at our company. And here is the entire demo, how it works. Again, all the infrastructure code is there. I have done all the heavy lifting for you. So all you have to do, download the lab, say serverless deploy, and actually see yourself how things are working. Thank you so much. I hope you have enjoyed this video, and I hope you have enjoyed this architecture, right? As soon as any item comes in, it essentially will broadcast those events to the data stream, and then the lambdas are processing the data, and then they are inserting into S3. I could have used a fire hose, and then I could have used a lambda as a transformation, but there was no need. I could have just done this with a simple data stream and a lambda fire. We are gonna build everything on AWS from scratch using Serverless Framework. This project is about essentially how we can essentially power our downstream user or enhance fan out from DynamoDB data. So what I'm trying to explain is, when any item is inserted, updated, or deleted, there are downstream user who would wish to subscribe to these events. So how do we build that, right? So let me show you the architecture and the code, and followed by a beautiful demo. So let's get started. So let me share my screen. So the architecture is fairly straightforward. We have a DynamoDB where the user will insert, update, or delete. Those events are captured and essentially broadcasted to a Kinesis data stream. A Lambda is subscribed to the Kinesis data stream, which receives data in batches. It will decode the data. It will convert the data from DynamoDB JSON to a regular standard JSON. It will also add certain housekeeping fields, which is essentially called metadata, right? So it's going to add all that. And after transformation, it's going to publish those events to an SNS notification. Now from the SNS, you can have hundreds or thousands of downstream users who are subscribed to those events, and each user can react or implement a certain business logic based on that event. For example, if there's an insert, you might want to do something else. If there's an update, you might want to do something else, right? So different events are broadcasted to the SNS, and the consumer can consume events basically based on their requirements. Let's build this. It's super fun. Again, please come to lab number 25 where I have all the code. So let's get started with the code session. On the top, I'm defining my service and the serverless framework. This is fairly straightforward, and there's nothing new here. And here I'm defining my tags and essentially my memory and timeout for my Lambda functions. .env true means inject all the items from an env variable. And here I have a function. The name of the function, again, lambda function dot lambda handler, which means there's a Python file called lambda function. Inside that, there's a function called lambda handler. We'll go over the code shortly, so don't worry. These are the environment variable that I'm injecting into the lambda function, right? Events, this lambda would be invoked via Kinesis data stream. And this is the on, this is the way to get the on after the resource is created. Here I'm creating a 3 resource object, which is SNS topic. Here you can see my SNS topic has been created. Here you can see it's my DynamoDB table, type as DynamoDB. Properties, I'm defining my sort key and range key, hash key and range key, or together called as a composite key. Then I'm defining my schema here. I'm using on-demand mode, which means I don't want to specify RCU, WCU. I'm using the standard storage class. By default, it is standard. I'm using point-in-time recovery, which is essentially backup on Dynamo. And essentially then I have my Kinesis data stream. So here is my on for my Kinesis data stream. So here is the part where Kinesis data stream has been created. It's basically on demand, right? After this is created, we reference here by using the word get ATT, and followed by .arn, right? So this will give you the arn. Now let's take a look at the Lambda function, what we have done here. So the Lambda function again is fairly straightforward, nothing new. We have two functions, marshal and unmarshal. These are used to essentially convert Dynamo JSON to a regular standard JSON. We have a class called SNS, which will help us to publish messages to the AWS SNS. Has a simple method called publish message to the SNS. We have a we have a function called flatten data dict. Basically, given a dictionary, this job is to flatten out the dictionary. It's gonna recursively call this function and it's gonna flatten this out. Over here, if you observe for record in record, we receive the records, we essentially decode the records and we deserialize the records. Once we deserialize the record, we get the event name from the records. And then I've declared a global variable, which is called JSON data. Depending upon the event type, whether it's insert, modify, or remove, we essentially update the variable JSON data. At the end, I'm essentially saying if the JSON data is not none, add the housekeeping field. These are housekeeping field, for example, source, name, event ID, region. And then all we are doing is we are creating an instance of a class AWS SNS, and then we are calling the method publish message to the SNS, and we are providing a message. The message is gonna be a serialized JSON, string JSON, right? And at the end, I'm just printing the length. So this, given all the items, whenever insert update happens, they go to the Kinesis data stream. Lambda is gonna process these data, and then it's gonna power my downstream user, okay? So let me show you this in action. This is amazing to watch, right? So I'm gonna say, so I'm gonna insert this event into Dynamo, and all this thing nearly happens near real time. So ready, create item, I have inserted, which means at this point in my architecture, if you observe, it will go to the Kinesis data stream, the Lambda will get the data, and then it will do the pre-processing, and then essentially will pass to the SNS topic where we have our downstream users, multiple users who are subscribed to these events, right? So now if we come to the, so here you can see is my SNS, and everything's done through Serverless Framework, right? So I have a simple subscriber that I have added just to show you. So this would be this one over here. I'm coming to the logs CloudWatch to show you. So I'm just gonna refresh. And here I'm expecting something to see like Sawmill, as you can see, right? Over here, Sawmill Shah, and let me try to zoom in, otherwise you'll say I'm lying. All right, so hopefully you guys can see now, right? So message published to the SNS, right? And here Sawmill Shah, that's the event coming from DynamoDB, right? So it's absolutely fun to build this everything from scratch, and you know, I was able to deploy this using a simple command called serverless deploy. And if you observe, here is my infrastructure code, everything very well organized in one file. Here are all my resources. All you gotta do is just say SLS deploy. I'll be explaining you a multi-region architecture, active architecture that is highly available, right? So this video will be divided into following parts, right? This will be an entire one video where first we will be learning about the architecture. Then the second part will be essentially deploying a DynamoDB global table in US East 1 and US West 1. Then we are gonna create an API gateway Lambda, right, with a health check using Serverless Framework, deploy that in the US East 1, then deploy that in the US West 1. After we do that, then the next part would be Route 53, how to link all of that together. Once we do that, then we do a weighted routing and essentially show you all of this in this video. We'll be using a library called DynamoDB, which is a DynamoDB client Python interface, which will allow us to insert item into DynamoDB much more easier. So we'll create layers, all of that is there in this video. I hope you are gonna enjoy it. Let's begin the tutorial. My first step is essentially creating IAM keys, that is access and secret. All right, so the first step of getting started with active architecture multi-region is let's get an access key, IAM access key. So let's head over to IAM and I'll click here. So I'm gonna be creating an admin keys right now. Of course, you can fine grain based on the permission you need, but for this tutorial purposes, I'm gonna be creating a master key just for explain, because I don't want to deal with permission issues right now. I want to focus on the content here, okay? So so I'll type the username as s.shah, or I can similarly say Saumil. I'll click on access key programmatic, click on this button, and I'll simply attach administrative access for now. So I'll click here, click create user, and then I'm gonna copy these keys on Notepad. Don't worry, these keys are gonna be deleted after the video, so don't worry about that. So here is my access key, and here is my secret key. I have copied that on the Notepad. Okay, so that's that. Now let's essentially see the architecture and talk a little bit about that, and let's start building the modules. So here is the architecture that we are about to build on Amazon Web Services. So on a broad level, you will have a client, maybe a front end or a mobile app that's using your microservice. This microservice can be very critical, that's maybe handling payments or something very important that cannot afford any downtime. And you also need high availability, which means you can't afford any region to fail. If anything fails, you want to easily move to a new region, right? So taking this architecture, as you can see, you'll be hitting up a Route 53 or a custom domain, for example, soundilshah.com. As soon as you hit that, based on the routing rules, either we have defined a failover region, failover model, or a weighted routing. If it's a weighted routing, 50% of the traffic would be distributed to the in the region A, that is US East 1. 50% will be essentially devoted to the US West 1, right? Each endpoint will have, each of the API gateway or the microservice will have a health check endpoint, which we are gonna add a health check in the Route 53. Now, anytime any health check is unhealthy, automatically it will switch or route the traffic to a different region. Now, the beautiful part about the project is the DynamoDB global tables. We are going to implement a DynamoDB global tables. So we're going to replicate the data in a US West 1 as well, which means whenever a request goes to the US West 1, it would essentially hit the DynamoDB replica. And as soon as the data is inserted into DynamoDB US West 1, automatically it's replicated in the US East 1. So the data is highly available, irrespective if any of the region goes down. Our DynamoDB backend is still there. The traffic would essentially, we'll go to a failover model, which means we switch over the region, right? So this is the architecture we are about to build. So the first part, we essentially got the IAM keys. Second part, we essentially showed the architecture. Now the part 3 is essentially building this global DynamoDB tables, right? So let's go to part 3, where we essentially build the DynamoDB tables using a serverless. Alright, so it's time that we essentially do our first stuff, that is essentially create a DynamoDB global table using a serverless framework. As I promised, I'll go slow, and this would be I'll try my best so that beginners can also pace up if they want to try. So the first thing that I want to do is I have created an empty project called multi-region, and I have created a GitLab repository here. So I will clone this and I will start writing code. All the code should be here. So you will have everything, you will have steps here. So I'll make sure that everything is well documented so you guys can follow the steps. So the first thing that I need to do, guys, is first of all, I need to open here in terminal, and I'll simply issue a clone command. And I would clone the repository here in my local directory. So as I said, I'm gonna go slow, but if you wanna go fast, please forward the video. I am gonna go slow here. So the first thing that we have is we have to configure the serverless framework, right? So if you come to this repository, and I'll leave the commands as well. So the first thing that we need to issue, npm install -g serverless. So this will install the serverless framework, so we'll write this step down so people can follow these steps as well. So we'll write install serverless framework, and I'm gonna copy this and I'll put this in the quotes, and here you can see now so essentially, remember, when we do something, we want to document everything so that when people are viewing the video and they go to GitHub, he's like, oh yeah, this makes sense, this is how we did, oh this makes sense, you know. So that's that, right? So now my first step is ready. Now I'm gonna do is I'm gonna create a directory here for my DynamoDB deployment. So I will create a directory called, so this will essentially hold my DynamoDB global table. So now I'm gonna essentially come to a repository. As I said, guys, I'll try my best to go over the code, so don't worry, right? I'll go slow. I'll make sure that you understand everything. So now I think I have a repository called DynamoDB. I'm gonna copy the source code, but I'm gonna explain you, so don't worry. So we'll copy paste this one for a second, and I come here. I will copy the file name as serverless.yaml. So inside that folder, we'll create a file called serverless.yml file. Now I'm gonna copy this and I'm gonna explain you everything step by step. So the first step is to create the tables, right? So before that, let's configure our serverless framework. So remember we created the IAM keys and stuff, right? So we'll go to the README file. We'll copy this command, okay, and we'll replace the keys where it says XXX. So I'm gonna copy this over here. Oops, let me see if I have copied this correctly. So I'll right click, copy, highlight the one that says X, paste it here. Then copy this as well, highlight the X and dump it here. So my command is ready. Now what I need to do, I'm gonna open this GitLab and I'm gonna say open in terminal and simply issue this command, okay? So this will update my serverless with the appropriate access and secret key, which is very important. After you issue this, you should say something called profile default has been configured, which means you're good to go, guys, okay? So now back to my DynamoDB deployment where I have my YAML file. I'll collapse and I'll start explaining one by one what we are trying to do. Org essentially means an organization. For example, if whatever company you have, Google, Amazon, whatever, you can type the name. App, so we're gonna say multi-region active. A service is DynamoDB global tables, right? So I'll put the service name. Version I'm using 3, serverless version 3. Over here we have provider, which means we're telling it we're doing this for AWS. Now we have a resource object, resource, right? So this is essentially, a resource that we're gonna create. I'm essentially here saying we'll try to go slow and steady here. I'm saying that I want to create a table called my table, and you know what, we can actually give some meaningful name here, right? So what we will do is we'll give this table so instead of that, let me see what data I was storing. Yeah, some email address, a fake email address, and user ID, right? That's fine. It's a faker data, so so let's name this table as users, right? Let's name this table as users. Okay, then we'll say type as DynamoDB global table. This is telling that we are about to use a global table here. Okay, so now coming here, table name again will be providing users. Billing type as pay per request, which means I want to use auto scaling out of the box. Now over here, what I'm essentially saying that my table has a partition key as email address, which will uniquely identify my row, okay? And my sort key is gonna be a user ID. That's my sort key that I'm about to use, right? Then key schema, I'm defining just a schema. So as you can see, email ID is a partition key, and this acts as a sort key, and together they both act as a composite key. Together the partition and the sort key has to be unique, which is satisfying the criteria. Stream specification, since we want to use replica, we have to specify this, and now I'm saying region as region 1, US East 1, US West 1, because my microservices are gonna be in 2 regions, that is US East 1 and US West 1. All right, so my serverless is ready. Now what I want to do is I want to open it here in terminal, and remember I'm just deploying my DynamoDB table. So back to my README file, all we are trying to deploy is the DynamoDB global. Then we'll create API, Lambda, DynamoDB, all that in a second. So we are working on the first component at this point, and let's clear the screen and say SLS deploy. And now do mind, this might take roughly about I guess 4, 5, 10 minutes. Okay, we have an error and we'll try to fix that. Please contact support. This identifier reference to issue this one. Okay, stack AWS Dynamo global table failed. Okay, So the reason that has failed, and I have an idea. I think the service, because I have a account with serverless with that particular name. So let me try with this particular name. So let me try. I think the app name also. I think because when I made my account, and if I try to change this to demo, hopefully I should resolve this bug here. Okay. Reissuing my command serverless deploy, and hopefully at this point this should have been resolved, because when I made my serverless framework, I mean when I installed it, so the region under which it was configured was demo app, right? I'm using a free version. They have a paid subscription version as well. If you want, you could opt in for that. So heading back to my management console, if you observe here, I do not have any Dynamo table here, okay? So I'm closing all the other tabs that are not required, so we could focus on one particular thing. Okay. So if I go to tables, absolutely I do not have any table, and I'm on North Virginia side, okay? And as I said, we gotta be patient. Please feel free to skip the video when required, right? So all we are doing is deploying a global table here, okay? I'm simply waiting at this point so that the stack is deployed. Now, once the stack is deployed, it's important that we populate essentially this with particular data, right? We'll do that in a second, okay? So, but let's try to be a bit patient here. So all this is doing is just creating DynamoDB table, okay? That's exactly what we're trying to do here. So let it build, and again, as I said, be patient, right? We will go slow in this video. There is no hurry at all. Irrespective, the video takes 40, 50, 2 hours. What's important, we go slow and everybody enjoys this tutorial is what is important for me. So I'm just gonna wait so that this is complete. And then we are going to populate DynamoDB with some fake data. We are going to make sure that the data goes to US East 1, US East 2, and so on. Sorry, US East 1 and West 1. And we are doing East and West region. That is California and North Virginia, okay? So I'm coming back, hopefully. Yeah, as you can see, the user table has been created. Email is the partition, sort key is the user ID, right? So essentially that's that. So I'm going to wait. DynamoDB standard, and here I'm just simulating any table, right? I'm just trying to show you the concept on a big picture, right? And remember, DynamoDB has something beautiful called tags. So if you have a lot of read oriented queries, you could implement DAX on the top of that. So yeah. This will take time, guys, so just be patient, okay? Also, what I'm gonna do, so this was DynamoDB deployment, right? So I'm gonna create one more directory here. I'll name this as DynamoDB populate. So DYNAMO. So this will populate the tables with some data. And again, I'm gonna create a Python file called run.py. The job of this is to populate DynamoDB with some fake data, okay? And we'll go over the script in a second because I already made a tutorial, so I'm gonna take the code from that. But remember, you will have everything that you want, okay? So as you can see, the DynamoDB has been deployed, and the first step was to install serverless. Once we have done, now I think the next step that people want to follow is step 2. I'll try to pull this off because this is little annoying. Is there a way I can? No. Okay, yeah. So step 2 in my README is create tables, right? So we'll provide the commands that we have used in this session. So we'll do this and we'll say cd, and you guys have to go inside this one, right? And then say SLS deploy. So that's your step number 2. Okay, hopefully you guys should be following with me. Once you've done that, then step 3 is to populate DynamoDB with fake data. So we'll write step 3. Okay, so for that we need to cd into this folder. As you can see, right, I'm providing every single step, so and the code. So then please learn, guys, try out. Okay, don't all I'm trying to say is don't make excuses. Unless you try, you're not gonna learn. I had to spend several hours and days learning this. So you'll come here and I have a file called add data. So now we're gonna run this file. I'll click on run and I'll explain you what we need to do. Okay, so we'll click on run and then I have this code here. So before that we need to install a library, so cd into that, and then we need to install DynamoDB. So we'll say DynamoDB pypy, and I'll give you the command as well. I'm providing you every single thing. Okay, so pip install that. Okay, so now once you have installed that, now you will say python run.py. Just run the freaking file, that's all. Okay, so over here we'll come here. Now we need to dump our access key. So for this project I was using this, right? So I'm gonna dump here. So what is this doing? I'll try to explain again. I have an array essentially which says US-East1 and US-West1, but before that let's go to management console and verify. I'm on North Virginia. Hold on, you won't be able to see because my photo. So I'm on North Virginia here, and if I drop down to California, I should see the same user table with the same settings. Okay, so if I head over here, I see the very same table here. Okay, so so you guys should be good there. Now what I need to do is, here I'm essentially inserting 5 records. So random region is equal to random.random. So randomly it's gonna select a region, right? I have a model here defined. So my table name is gonna be users, remember. So we'll say users. This will change here. Access key, and the region I'm selecting at randomly, so I can pump some data. We'll try to populate with 10 items here. Email address, right? So I've defined the schema here, as you can see, and then I have faker library. I'm generating the data, fake email, fake user ID, right? Some bunch of random user ID, first name, last name, company, and region, right? So generating some fake data here, as you can see. Let's call this. So we'll put this in a variable called response, inserting into the region, and then we'll say we will format this a little better. Okay, and here I would use the comma, and let's dump the response here. So now we should have some fake data here. Okay, so 10 items. So now I would right click and click on run. So given the access keys and all are okay, and remember I don't have any data. Okay, so I'm just inserting data. So if I click on explore, I don't have anything, but now I'm started the script. So now it's gonna randomly select a region, and as you can see, it's been dumping data, right? So 10 items, US to West1, East 1, West 1, right, into the appropriate region. So I'll come back to the table, click on users. Hopefully I should see that. So we'll click on explore table items, and if we scroll down, I think there is a small delay here. Yeah, there you go. So I have all the data, and as you can see, I've inserted data into different region, US East 1, US East 1, US East 1, right? So I have the data, and let's see if we have inserted something into the US West 1. So yeah, we did insert into US West 1 and some into US East 1 as well. So now we'll wait so that, oh, you have US West 1 too. You see, So I mean the data is there. If I go back to my California region, that is US to S1, I should see the same data there, because Dynamo behind the scene is replicating my data, as you can see. So data is there in both the region, right? US East and US West. Okay. So heading over back to North Virginia, heading to the user tables here. Okay. Now what I'm gonna show you is that cloud serverless script that we wrote to generate the Dynamo table. If you go to global tables, you have a, as you can see, you made a replica, right? So that's that, right? So the first two steps that we did is we created a DynamoDB table, and then we populated with some fake data. Now our goal or the target is essentially to generate APIs, right? Each API would be deployed in US East 1, US West 1. Then we do all these fancy stuff, right? So that's gonna be the next step. So now the next step actually is to get Route 53. So I'm on my North Virginia. I'll try my best to show you the steps again. So I'll close this, I'll close that, I'll click on Route 53. For this demo, you have to purchase a domain. It's usually $12. So I would say pay the freaking $12 and learn it, okay? So yeah, come to registered domains here, right? I already have purchased one called saumilsha.com. I'll show you how to do that. Register domain, and now here you want to say Saumilsha 1995. It's gonna be $12. You can check. So here you can see the domain is available. You can click on add to cart. This is not refundable. Okay. So that my address and things were visible, right? So yeah. All right. Heading back to Route 53. Assuming you purchased a domain name, right? And you will see that in the if you come to registered domain, you will see that particular domain here. I already have done that. The next step is to register or issue a certificate. So come to certificate manager. Now we need to create a certificate here. I already have it, but I'm going to show you. Request a public certificate. Now here what you want to do is you want to say, you want to type the exact domain name, and then you also want to say star. That's going to be dot. So this means that anything that matches .saumilsha, do that. Once you do that, click on request button. Okay, so this will essentially request. This will be pending. Now I'll show you how to fix that in a second. Now head over to hosted zone over here, which says hosted zone. I already have one, but I'm gonna show you how to set that up. Okay, so a very important step here is first of all we need to come here and delete. So I'm replicating exact same steps. Yeah, it's not gonna work because I have a CNAME here. I need to remove the CNAME first. So I'll delete. Click on delete. Okay, so now hosted zone. Click here. Click on delete. So that I can walk you over the steps. All right. So you'll see a screen like this, right? At this point. Now you wanna click on create hosted zone. Okay. Now here, type in your domain name. This is my personal domain. Okay. Tags, if you want, please add tags. Now here is the step that is important, and a lot of people I think miss that step. You see these values here? You need to actually link this, guys, otherwise it's not going to work. So I would copy this, come here to your notepad and paste that here. Okay, so I've pasted that here. Now head over back to where it says register domain. Okay, and I'll try to zoom in because I don't want to show you my address. So I'll click here. Okay, so you see this here, this should match that one. This doesn't match the one I have. So the way you wanna fix this is you wanna, and remember there shouldn't be any dots. Okay, so we'll click on edit. Now observe this carefully. I'll try my best to put it here. Hopefully you guys can see, but NS113, I do not have anything that says NS113. So I'll start copy pasting here. .net .org .com. Okay, and then you want to click on update. Very important step, you have to do this. Okay, so once you're done with that, this will send you an email essentially in a second or two. Now once you've done that, then head over back to your hosted zone. Okay, so all you're doing is just setting up your domain and Route 53 at this point. So head over to hosted zone, and now this is a very important step that we need to do. So your certificate will be pending. Now click on create record in Route 53, absolutely important, right? And here you will see the button coming up. I already have it, so it's not going to show up. So it will say create record, and then you want to click on that. Once you have done that, what you would see here is you will see a CNAME. I don't have that because this will take a bit of time. They're going to send me an email, and once I get that email, I should be able to add that particular part. Okay, so now hopefully you guys got an idea on how to set up Route 53. We purchased a domain. After we purchased a domain, the steps was we went and we clicked on hosted zone. The servers that we got, we went to the we went to the registered domain, we click on edit, and then we edit those particular information there. Okay, once we done that, we create a certificate, we request certificate, and then you have to link the certificate to the Route 53. Very important step. As you can see, right, I did receive an email from Amazon updating the domain details for soumilshah.com succeeded. Dear, we have recently received an online blah blah blah. So they updating blah blah blah. Okay, so as you can see, this email is important. Okay, if you haven't received, your certificates are going to be pending and it's not going to work. Very, very important. So you should receive an email, and then we need to link essentially the certificates here. If you come here, of course this wouldn't work because so if I try to link this, this wouldn't show up, right? So what I'll try to do here, just to show you guys, this is no good. So we'll click on delete. So now remember, we do not have a CNAME here. Okay, so I'll click on request. Next, now here soumilshah.com, we'll say star dot, okay, request, and now I should see this, but again remember it's gonna be in pending state. So list certificate pending, right? So now we click on create a record in Route 53, we click on that, and if I refresh, you'll see a CNAME here, which is exactly what we wanted. Now coming back here, this should change the status hopefully in 5 to 10 minutes. There you go, right? So that's how you link your Route 53 and certificates and all of that with domain name. So the next part comes is essentially we need to essentially write our API or DynamoDB, whatever API, right? We made the global tables. Now let's write these. So it's time for creating our microservices, right? DynamoDB is done. Route 53 is done. Now we'll create our microservice. So I'm gonna create a directory called myc. So this is gonna be my API gateway that's gonna do the job, right? So now since I need an external library called DynamoDB, I'm gonna be using some code that I had from my previous tutorial. So these codes will help me essentially build a layers, right? So over here, now coming back, and I'll try my best to show you all the steps that I'm doing. So requirements.txt. So I'll essentially go into my folder called microservice, open this in terminal, and I need to see what version of DynamoDB I have. Pip. So I'll do pip show DynamoDB. Okay, so hopefully this will show me the exact version that I'm about to use for the tutorial. Okay, so let's wait. Might take a second or two. Ideally that doesn't take that long as far as I know, my knowledge is concerned. What I'm gonna do is just put the library name, it's fine. So I'll go to again here. Oh, by the way, I think I have it in the readme file. Oh, I think I got it. So I'm using version 5.2.1. So we'll come here, change this to 5.2.1, remove the space, go to the readme file, and here is where I have DynamoDB. change this to DynamoDB. Okay, now I need to define my lambda. So I'll define, as you can see, I have a scaffold here which shows all the stuff how to do that. So I'll copy this. This is gonna be the lambda. It's gonna be, yeah. All right. So we'll define our handler function here. Okay, now I'm gonna copy the scaffold code over here in a second. Okay, so as you can see, we copied the scaffold code. So over here now you need to use DynamoDB that I'm gonna do. So pyna, so import DynamoDB. I'll do that, and we'll remove all these because we need to start filling up code here. Okay, so that's that. We'll say get let's say, we'll do a get record from DynamoDB. Okay, that's fine. So the API will receive a JSON, right? And then we will write the logic here. Now another thing that I need to do is I need to have one more Python file. We'll name this as health. So this API essentially is a health check for API gateway. I don't need this one. This is usually used when we are using external packages. So what I'm gonna do is I'm gonna say health check. We'll do return. I should have copied the snippets. I think I can copy here. So we'll say so this will be a status 200 and the microservices are working fine. Essentially a health check, right? So I think I could do something better here. Could just name this as check. Remember, I still have to write my DynamoDB stuff. I haven't written that here. So that's that. Now I need to define my serverless.yml file. So I'll define that in a second, and then I'll try to explain you what I'm trying to do. And remember, I've done all these tutorials. All I'm doing is now combining all this tutorial into one stuff. So I'm gonna explain you what I'm trying to do here, hopefully, in a second. So, okay, so over here, I'm using Python version 3.6. Service name, I'm trying to give a service name, so I can say, we'll name this multi-region APIs. Okay, there is a package that I need to install, which I would install in a second. Then we're using a zip file, right? So it's gonna deploy the code using a zip file approach. We'll take this comment off, right? And we'll take this comment off as well. So essentially we are, excluding all the other files. We just wanna make sure that we only put Python files in the Lambda. Here I would need to change a couple of things. Hopefully I do have my scaffold here. I think that was lab number, if I'm right, is lab number 8. So now this function needs to be invoked on an API gateway, right? So I'll try to copy this scaffold here, okay? Put this here. Now the name of the function will be I'll name this as get users. So this is gonna be handler dot get records, remember? So we'll define this as get record. HTTP path as /hello. So we'll say get records. So based on an email address, we wanna get a record. We can change this to a get request ideally, or we can make it a post request because it's gonna take a data attribute. I'm gonna make this API as a public, right? So I'll do that. Let me remove this one. Okay, so now that's that. Now we need to define a one more health endpoint, right? So one more we have. So this is gonna be, I'm using camel case here. Okay, you can use whatever you like. So get users, right? And here this is gonna be the health point. So health, and inside that we'll have a dot check. Okay. I ideally health endpoints are get requests, so we'll change this to get request, right? So all we did is essentially we have two lambdas that are gonna be fired on an API gateway. And remember, I have to still install this library here. So what I will do is I'll close this and I'll go in the top directory, click on open in terminal, and we'll copy this and we'll try to Google this. So we'll come here. Usually serverless tells you that when you want to install stuff, so should be an npm somewhere here. Oh, here, there you go. God damn it. Okay, so now I'll try to update my readme file again. So we come to here. So we did populate the DynamoDB. That was the step 3. Now step 4 is cd. So you wanna cd into a microservice, right? And then we wanna say, of course I have to write code. Okay, so SLS deploy. So that would be my step 4. Okay, so that's gonna be that. Now I still have I am not done yet because I am yet to test a stuff. So I'm gonna say so here I just want to test a get item, so temp. So I'll copy the DynamoDB. I'm just gonna copy paste irrespective whatever region, it doesn't matter, to be honest. So I'll remove certain code here, right? I'll keep this class because I definitely need that. Okay, I come here and whatever region, as I said, doesn't matter. USD is 1. Okay, so that's that. Okay, all right. So all I'm trying to do is given an email address, it should return some data, right? So I want to test that out. So I'll comment out all of these. So that's my user model. Okay, those are my keys which will go into an environment variable, and I'm just testing my code. Now I do remember that I wrote a blog in the past. So I'm gonna try to go to my blogspot and copy certain snippets out there. So DynamoDB help, right? So I did that in the past. So here my goal is to get an item based on a particular stuff. So I'm trying to see, yeah, this one. So I think the way you do that is query. Yeah, so that's how I think we use Pynamo, whatever. So for user in user model.query, and remember my partition key is an email address, right? So I'm gonna test this out to make sure it works. So given an email address, these are all fake, so don't worry. So user model.query, I guess it should work. We can do first name. So the name is Stefan. Okay, so that's that. Okay, so looks good. And what I want to do is I want to use a tool to format my code a little better. I'm a person, I like to do things better. Black, I'll use the tool called Black. Automatically it formats, and of course this will be in an environment variable, don't worry guys. Okay, so it did format that. Now let's see if this works. Okay, so all I'm trying to do is, first of all I'm trying to do is just make sure that this thing works. So given an access key, I'm sure enough it does work, right? So if I just do this, let me see what happens. So given a partition key, I can get the entire row, and my computer is slow, so bear with me, man. So yeah, I think it works fine, right? So now what I'll do is we need to get the JSON. There might be a command to directly get an entire item as a, but I'm just gonna, bear with me, man. So here, did I do that? I don't remember. Did I do it in my tutorial? I don't remember. It's fine. What would have been nice? What are the methods I can? Is there a data attribute here? DynamoDB. Because I don't want to specify dot first name dot line. I don't want to do that. So let's see if I try to do a str method. I'm pretty sure they must have overloaded the output operator. I think it should print in a, hopefully. Nah, doesn't like it. Yeah, that's fine. For this example, it's fine. Okay, so let's say I want to return based on an email address, I want to return the first name. So we'll say and we want to return the last name and the company. Okay, and then we'll try to test our API to see first if it works, and then if it works we deploy multi-region blah blah blah. And so company, okay, and I'll try to print this. All right, so we'll try to print this data and see if this works again. Okay, yeah, I mean ideally should be fine. Yeah, so yeah, it works fine, right? So now I have my code, I have tested things out, right? So what I'm gonna do now is come to the microservice part, right? In the handler.py, I'll try to, I'm just using these two guys, fine. So in the handler, right, so I'll define my imports. I'll define in a try catch. Okay, so we'll copy the test code that we wrote. I'll define the class here. Remember, we still have to provide this one. So this will be coming from an environment variable. All right, so we'll remove that. Import OS. Now we say os.getEnv. We'll do and I still haven't defined the environment variable yet, so we'll remove this one, put this one as there, and format this, try to have the same thing here. AWS. All right, so that's gonna be that. Okay, and my Lambda, remember when I call the API, it is essentially first for debugging. Has been a while I've done some, so we'll do print event. We'll do like this. As far as I remember, I think it comes inside a body, but I might be wrong, as I said. So that's that. Now if I remember this correctly, as I said, it's a JSON. So it's gonna be a string JSON, so we'll do a load s and we'll try to do body, and once we have that, what we will do, we'll copy this code here. So remember, we want to grab the email address. We'll use the get operator, and it's gonna be email, and we'll remove this one. And if we find data, we return, else we return we'll copy the health check. Okay, come here. Wanna do a dump as here as well. Okay. So yeah, my very simple API, wait, what do I do? Yeah, you know what? Yeah, it's fine. I could have done this here only. Could have removed this. That's fine. And if nothing happens, by default, it would return the message. So yeah, very simple API, right? That essentially is gonna give us a record from DynamoDB. And remember, this API will be developed, deployed in multiple region, right? So handler function, region value, yeah. So this is gonna be, I have to also make sure in my model that I wrote here, yeah, this is region, and of course the table name also can be an environment variable. Let's just put that, man. We'll use this one. Okay, put this one here. All right, so the API is ready, but I will clean the code here. Now I'll use black handler.py. Automatically it indents everything properly for me, and then I'll do healthcheck.py, so that would be also done. Okay, I have to deploy and I have to do some more changes, so let's do that. But let me just see if it looks good. Okay, that looks neat enough, pretty nice. All right, so now a couple of more steps. We just gotta define this environment variable. Of course that can come in a variable called dev.env or blah blah blah. Well, let's do that in a second. Yeah, so as you can see, right, I have installed all the plugins and I've initiated the command SLS deploy. So this would essentially deploy my entire stack here. Okay, so we'll be patient, right? One thing that I have added is a plugin called .env. If you observe in my secrets, I put everything in an environment variable, right? In order to inject that, there's a plugin called serverless.env plugin. So the next steps essentially in the project are to install that plugin, and here, step 4, we deploy the microservice, and I have set the command cd into this. We install these two libraries and then deploy. So now my microservices are being deployed. Okay, so let's wait until this entire stack is deployed to UST2. So after a long wait, finally my APIs have been deployed. It took a long time though. So now since it's deployed, I can come here and see if the health check is okay. And at the same time, my Dynamo also works. I gave in an email address and it's returning me the result, as you can see, just the way I expected, right? This was inserted using US West 1, so it's returning that. All right, great guys. So the stack has been deployed. Congratulations. 80% is done, right? Rest remaining, right? So if you close that one. So if you come here to API, and if you come and click here, you should ideally see your stack here in this region. So as you can see, multi-region, right? So this is in US East 1, North Virginia. Now what I'm gonna do is I'm gonna deploy the same stack, but in US West 1. So I'll say, so I am gonna do one change here. So in the env here, since I'm deploying in US West, I'm gonna change that, and SLS deploy Now again, this will take a couple of minutes, right? So I'll copy this in a notepad, so hopefully I can show you. So we have a API in the North Virginia, right? And then we are now deploying the API in the US West, that is California, right? So that's that. I'll remove this one here. So that's gonna be my US East 1, 1, and now I'm deploying in US West 1. So deploy this. So now this API will have the same API, same microservices been deployed on multiple region. Now so again the California is being deployed, the API there. So I'm gonna start building stuff here. So I'm gonna click on custom domain, click on create. We'll type somilshah.com. So I wanna add a custom domain name here. I'll select a certificate and then click on create domain. This will essentially link my API gateway to a domain, right? So now we'll click on API mapping, configure API mapping, add a new mapping. We'll select this one, stage as dev, and then click on save. So I've essentially done that. Right now, in order to test my scenario, right, since it's deployed in one region, I have completed here in my North Virginia, but I need to do the same set of actions in US West 1. So I'll wait for this to deploy in US West 1. This is gonna take time. And once this is deployed, then we'll do the same thing in the US West 1. So the API just has deployed in the US West 1 now. So I'll go to this endpoint and I see that. So I'll copy that in the notepad too. So here is my Word file and here is my endpoint here in the US West 1. So these are the two domains that I have set up, right? And I'll try to verify the same thing, hitting the API, but from the West 1, the same Dynamo table. So need to remove this guy, need to send the request. Ideally it should work. Remember it took a little longer because this is in California, which is, I'm in Stamford, New York, which is closer by to my region, right? So it took a bit long, but we got a response, right? So both of the APIs have been deployed. Now we do the same action on US West. So we go to US West 1, California, custom. Okay, hold on, let me see. Yeah, so this is here. Now we do the same side of action, somilshah.com, and here the certificate is not there, so I again need to do the same stuff here as well. So AWS certificate manager, I'm gonna go here and request a certificate here. So request, click on next, same thing, somilshah.com. somilshah.com. We'll click on request, and sure enough, I think it's requested. So you look at the region, okay? I'm on a different region. I'm not doing that in the US East 1 now. So I should show up here. So now, of course, this is pending. I need to again link this with my CNAME. So create a record in Route 53. And now my both the certificates should be linked successfully. Might take a second or two, or depending upon 5. Here you can see issued, right? So at this point in my architecture model, we are almost there. If I show you readme.md here, try to come here. So we deployed API Gateway Lambda and Dynamo. This one we deployed this sec block right here. Now all I need to do is just link things to a domain through DNS, right? So I'm almost there. So now I'll head over to Route 53 where all the magic needs to be done. So so this is a crucial part that we need to now do, linking of both the. So coming to the hosted zone, and now here the magic starts, right? We'll do the health checks in a second, but right now I want to do a simple, so we'll say, we'll do a weighted routing here. What am I doing? No, I don't want to create a zone. I already have one. So we'll come here, and now hopefully you should have your CNAME here, okay? So click on record, and we'll click on weighted routing, or we can do a simple routing first to verify that. We can do a failover model pretty soon, but let's do a weighted routing. So this one, sawmillshot.com. Oh no, this is gonna be blank because my API gateway is sawmillshot.com, remember. So here record type would be an A type. TTL, you can leave that to default, and you can define here. So here I'll say alias to API gateway. You can select the region to US East 1, and here you can see automatically it comes up. So here I'll say 100. Health check, I can provide a health check, but I don't want to do that. Evaluate target health, for now I don't want to do that. This is calling US East 1 right here. We'll click on the checkbox and then click on record. So now successfully we have entered an A type record with 100 differentiator. We do the same, weighted, next. Again, this is gonna be a new region, remember. So we'll select alias to API gateway. Now this time I'm gonna say US West 1, okay. An automatic, think I screwed something up here. Let's see, US West 1 California. Wait, did I select that right? Yeah, let's see, hold on. First let's verify whether I'm able to hit my domain correctly, which I'll try in a second. Come here. So hopefully that works. Oh, I forgot the HTTPS. All right, so copy, replace this guy right here. Okay, oh wait, I need to remove dev. Let's try, hopefully works. Yeah, so now I'm hitting my domain name, and essentially it's hitting my US East 1 region. At this point I just need to add that weighted routing, just something that I think I'm missing. So I think weighted routing, let's try again. So I'll leave this default. Okay, define a weighted here, sawmillshot.com. Okay, so here alias to API gateway US West. Oh, I remember why, because I haven't done the domain link. This part, yeah, makes sense. So hold on, refresh this one. God damn it, I gotta go back, hold on. So yeah, I'm on US West 1. I do not have a custom domain name. So sawmillshot.com. All right, so here you go. That's why I was like, I know I'm doing it right. All right, so that's that. Now heading over back to my Route 53, selecting the region. There you go, beautiful. So we defined a weighted routing, and here you will say US West 1, we'll put this one here. And by the way, congratulations guys, you have a full-blown multi-region model. So essentially, so try my best to draw here. So here you have your Route 53. When anytime a request comes in, it will 50% of time it's gonna go to US East 1, US West 1, right? So automatically you have your API gateway, Lambda, and your Dynamo, right? Global tables, right? So you have a full-blown architecture, man. So that's how you do that, right? So now if you had to plan to do a failover model, things are similar, I would say. So what we can do is, first of all, we'll delete these A type records. By the way, we can verify. Okay, so if I come hit the domain, it's hitting my Dynamo global. Now in order to delete, first we delete the record here. All right, so in order to do a failover model, right? So we need to head over to health check, create health check. This is a tricky because we go to the Word file and we copy the first region, okay? Hold on. So now in order to build a failover model, right? So /dev/dev, hold on. What was the health endpoint? I forgot. Hold on. I think here. God damn it. This one. Serverless. Okay, so health. Come here. Okay, so if I do that, oh, it's a post. That's why. Makes sense. So if I do that, god damn it, what happened? HTML public data transmission. Hold on. Yeah, hold on. Hold on. I know what's going on. Bear with me, okay? Bear with me. All right. So we'll go to US East 1. Okay. So API. Come here. I think it was /dev/health. I keep forgetting, whatever. So stage and stage. Click on dev. Okay, that one. So we'll okay. It's fine. Let's do this on a new tab. Okay, so that's that, and then I'll call a /health. It should work. Yeah, so that's that. Now we're designing a failover model, right? So what you need to do is where did my route? Yeah, so over here you need to put the domain name. So ideally, god damn it, this one. So you want to have this, right? Status of other check state of cloud. So put it as an endpoint. Okay. Oh, was there a name, right? So we'll put a health check of UST East 1. Over here, we'll select domain and we'll select HTTPS. Copy paste the domain for that region and port 44. Was it 443? I always forget it. I'll just verify that. Okay, 443 is SSL. Yeah, 443, and a path would be. God damn it! So this will be /dev/health. So the entire shit. Okay, so that's that. Failure threshold, you could define all that. I mean, so this is my endpoint, and we'll verify if this works. Come here. Okay. Oh, there's a double slash here. Hold on. Need to fix that. Hold on. All right, that should be good now. Okay, hold on. We have HTTPS 2 times. So, oh yeah, this we need to strip off. And there you go. Yeah, there you go. So that's good. Good. So click on next. Alarm, I'm not gonna do that, so you just create a health check, and here you'll see the matrix here coming in. Okay, so you'll see the green stuff. I need to do the same thing for the US West one. Okay, I'll go to API gateway, and now I'll switch the region. Not Ohio, I want to go to California. Okay, it's gonna load now. All right. So we go to California. Okay. I think I had in my Word file. So I think I can copy paste if it works. Sometimes it doesn't work. Copy paste. All right, it worked. So I have the endpoint. Now I need to configure that. Why am I on Ohio? So let's come here. So now again, domain name. We'll put it here. We'll strip off. We need to put it HTTPS. Strip this off, guy here. Okay. Path would be dev/health. So come back here. Okay, and then need to verify this on a new tab. This is the US West one. Hold on, something is wrong. Not right. Hold on. HTTPS west1.com 443 dev health. God damn it. Need to strip this off here. Okay, should be good. God damn it. All right, so I think now we are back. Okay, so it's good. Click on next. Click on health check. So now, as you can see, we have both healthy. Now, how do we do an active failover model, right? So the way we do that, now it's just a game of playing with hosted zone, okay? So the way this works is you have your CNAME, you create a record. Now you can do a geolocation as well, latency or failover. So I want to do a failover model. So this would remain same, my primary domain. TTL, you can define a failover. So value or route to matrix. So we'll say alias to API gateway. We'll define USTist1. We'll define that API gateway. Failover record type will be primary here because that's my primary region. Health check, we can put it here, and whatever you want to put, US. Okay, so we define that. Now again, one more, we need to define a secondary when the failover occurs. So alias to API gateway, US west 1, and then again alias here. Failover record would be secondary, west. Okay, US west 1. There you go, guys. Full-blown failover model. Now, as soon as so let me stop here for a second and then. So if I hit my domain. Okay, so now if I put this one here, god damn it, come here. So now if I put this Somil Shah, and now I'm hitting my primary region, right? So now let's look at the failover region. So I have a health check. Okay, so I'll show you that in a second. Both are green, right? So as soon as a region fail, it would automatically fail over to the different region, and your API will be still working. Okay, and the way we simulate this failover is we have to do manually on a Lambda, and I'll show you. So assuming my North Virginia USTist1 goes down, right? So so we'll go to health check here, and by default purposely I'm gonna, oh shit, I can't, because I deployed through serverless framework. Yeah, god damn it. So because I deployed through serverless framework, I can't like edit or tweak the code. I have to redeploy the stack, but hopefully you got the idea, right? So all you gotta do is I gotta put this as 400, and as soon as that happens, it would automatically do a failover, right? So the traffic will be all routed to US West 1, right? So it's that easy, right? So I hope you guys have really enjoyed these all videos on DynamoDB right from zero to hero. At least you have learned some important concepts and labs, right? I hope you have enjoyed. I hope you have tried out these labs. And if you have any more questions, please list your question in the comments below, and I'll be very, very happy to talk or discuss about that. Thank you so much for joining. Please make sure to hit the like and subscribe button, and do share the video with your coworkers if you find value out of this, right? All the resources, the slides, the material, the lab, everything is there in the description. So please feel free to check those resources out. Thank you so much, and I'll see you in the next.